Hey there! Today we're going to learn how to calculate the missing side length of a triangle. I'll show you everything step by step, from the basics to real examples. Let's get started. Let's start with the basics. In a right triangle, one that has a 90-degree angle, there are two main ways to find a missing side. The first one is the Pythagorean theorem. We use the Pythagorean theorem when we know two sides and want to find the third. The formula is a squared plus b squared equals c squared, where c is the hypotenuse, which is always the longest side, and a and b are the other two sides. The second method is using trigonometric functions. We use these when we know one side and one angle, other than the right angle. The most common functions are sine, cosine, and tangent. For example, sine relates the opposite side to the hypotenuse. Cosine relates the adjacent side to the hypotenuse. Tangent relates the opposite and adjacent sides. So depending on what you're given, you choose the right one. And if the triangle isn't a right triangle, don't worry. We'll use the law of sines or the law of cosines for that. Let's go through our first example. We have a right triangle with sides 6 and 10, and we want to find the missing side. So we apply the formula 6 squared plus x squared equals 10 squared. That gives us 36 plus x squared equals 100. Subtract 36 from both sides, and we get x squared equals 64. Taking the square root, we find x equals 8. The missing side is 8 units. Here's another triangle. This time the hypotenuse is 16, and one side is 9. Again, we use the Pythagorean theorem. 9 squared plus x squared equals 16 squared. That's 81 plus x squared equals 256. So x squared equals 175, and the square root of that is approximately 13.23. The missing side is about 13.23 units. Now let's solve a triangle using sine. In this triangle, we have an angle of 30 degrees, and the hypotenuse is 50. We want to find the opposite side. We use the sine formula. Sine of 30 degrees equals opposite over hypotenuse. That's sine of 30 equals x over 50. And since sine of 30 is 0.5, we get 0.5 equals x over 50, which means x equals 25. So the opposite side is 25 units. This time we'll use tangent. We have a triangle with a 60-degree angle and an opposite side of 100. We're looking for the adjacent side, so we use tangent of 60 degrees equals 100 over x. And since tangent of 60 is approximately 1.732, we get 1.732 equals 100 over x. Cross-multiplying, x equals 100 divided by 1.732, which is approximately 57.74. The adjacent side is approximately 57.74 units. Now let's look at a triangle that's not a right triangle. Here we'll use the law of sines. We're given angle A is 50 degrees. Side A is 10, and angle B is 60 degrees. Using the formula, sine of 50 over 10 equals sine of 60 over B. We plug in the values. 0.76, 6 over 10 equals 0.866 over B. Cross-multiplying, we solve for B. B equals 0.866 times 10, divided by 0.766. That gives us B is approximately 11.3. So side B is approximately 11.3 units. And finally, let's use the law of cosines. We use this when we know two sides and the angle between them. In this triangle, side A is 8, side B is 6, and angle C is 60 degrees. The formula is c squared equals 8 squared plus 6 squared minus 2 times 8 times 6 times cosine of 60 degrees. Since cosine of 60 is 0.5, we get c squared equals 64 plus 36 minus 48. So c squared equals 52. And c is the square root of 52, which is approximately 7.21. So side C is approximately 7.21 units. And that's it. Now you know how to calculate missing sides in any kind of triangle. Right triangles with the Pythagorean theorem, using sine, cosine, or tangent for angles, and the law of sines and cosines for non-right triangles. If this helped you, make sure to like, subscribe, and leave a comment below. See you in the next one.